Hi, welcome to this lesson on analytical geometry, tangents to circles, part 1. Let's have a look at question 2. We're given the equation of the circle, so it's given in the form x minus h all squared plus y minus k all squared equals r squared. So r squared is 136, and here the center is going to be -4 and -8. Okay, always the opposite signs here. We want to find the gradient of the radius at the point Q22. So here's the point Q22, and the center point is somewhere down here, C, which is -4, -8. Okay, so the circle will look something like this. Okay, so the radius line, R, okay, so you can see it's going to be a positive radius, right, because it's increasing from left to right. And from -4 to 2, that's 6 across, and from -8 to 2, that's 10 up. So the the gradient is going to be rise over run, 10 over 6, which simplifies to 5 over 3. Okay, so that is the gradient of the radius line. Next, they want us to find the equation of the tangent line to that same point Q22. So again, if I draw that point 22 there, the center C is -4, -8. Okay, and we drew the radius line. So we want now the tangent line. So the tangent line is going to look something like that. So based off of that, it looks like it's going to have a positive y-intercept and it's a negative gradient. So let's work it out. So we have that the gradient of the tangent times the gradient of the radius must be -1. And again, that is because the tangent is always perpendicular to the radius. So therefore, the gradient of the tangent times the gradient of the radius, which we worked out as 5 over 3, is -1. And then if I just solve for the gradient of the tangent, so multiply by 3, divide by 5, I get -3 over 5. So that's the value of the gradient of the tangent. And we expected a negative value. So that makes sense. So far we have y equals -3 fits x plus c. And now I'm going to substitute the point of contact, which is Q22. And I'm going to get, so y is 2, and then x is also 2, plus c. Okay, so I get 2 equals, so -3 times 2 is -6 over 5 plus c. I can change 2 to be 10 over 5, right? So that has got the same denominator, equals -6 over 5 plus c. And then I can add 6 over 5 to both sides, and I'll get c equals 16 over 5, which makes sense because that was going to be a positive value. So, therefore, we have that the equation of the tangent line is given by y equals -3 over 5x plus 16 over 5. And that is the equation of this tangent line at that point. Awesome. I'll see you in the next one.